Okay, our next exam is coming up, and here's a little bit of a review on what we're covering. In this exam, it'll be similar to the last one, in which you will show up to your assigned day and time and download the Word file from the Dropbox, and then complete the exam in class and resave your file, and then upload it to the Dropbox. That seemed to work quite well last time, and we'll just do it the same way this time. Our exam is over the last 3 study guides, so weeks 5, 6, and 7 from Module 2 on digital audio. And so our focus is on the digital realm, and so we will basically cover these elements from these study guides. This is basically from the first, the second, and the third study guide from this module. So be able to identify and explain what an analog to digital converter is, and vice versa, the DAC. And it's best to associate these terms together. So CD quality audio standard is your full standard audio file, then AIFF or WAV. It has a bit depth of 16 bits and sample rate of 44.1 kilohertz. Those values you will need to know. Please also know what the Nyquist theorem is and what quantizing does. This is all basically about the sampling process when digitizing audio. And we also talked about file compression and the MP3, lossy, lossless, and those terms. And those all sort of go with the file types concept. So be able to identify a uncompressed file type like an AIFF or WAV, and a compressed file type like an MP3, for instance, and describe what happens when we compress an audio file. We'll also talk about the digital audio workstation, what destructive editing versus non-destructive editing means. Basically, we talked about how destructive editing alters the waveform itself. Non-destructive editing does not. It passes it through a plugin or some sort of other processing type. Be able to describe what a plugin is, and identify a pan knob and describe what gain versus master means. Basically, gain is the input level of a mixer or a DAW. So gain means that we're altering the amount of volume going into the mixer channel or the DAW input channel. The master is the summed output of all tracks or channels, mixer channels. So gain is basically volume going in, and master is volume going out. And there's a big difference between those two things. 0 dB means that there's no change to the incoming signal or the outgoing signal. That doesn't mean silence. 0 dB means that we're not changing the volume. So from 0, we go either plus or minus. So we go to minus infinity for silence, or maybe plus 2 or 3 on the plus side. But remember that we are dealing with positive and negative integers with our decibels now that we're in a editor or some sort of a virtual mixing console. I/O settings refers to the in or out settings, audio input or audio output settings for a DAW. All digital audio workstations will have I/O settings available, so you can route your audio to certain places. Be able to identify what solo, record, and mute buttons, transport controls, and things like that. Be able to identify the filter types that we know, and those are basically applying to what an equalizer is, or an EQ. And reverb and delay, those are very similar. But delay has basically a time element to it, where you are hearing the playback of the audio according to a timeline, and stored in a buffer and replayed in a timeline. Reverb is a bunch of delays sort of packed together, so you get the sense of ambiance and environment. And so reverb is a bunch of delays really close together, and that gives you a sense of reverberation. Bouncing or bounce is how we render an audio session to a stereo track. or stereo audio file. In GarageBand, they call that share, but most DAWs call that bounce, where we bounce to disk. Dynamic compression. We talked about how sometimes, especially in the popular music realm, audio files are dynamically compressed so that the high impact amplitudes are sort of shortened, and so that we lower that headroom of volume, and then we move everything up at the end. So that makes for a very compressed audio dynamic range. And then automation is how we change parameters over time. And pitch and time shifting is interesting because in the digital realm, we can alter pitch and time separately. In the analog realm, if we slow down a record or if we play a tape back slowly, the pitch and the time are altered. However, in a digital realm, since it's all numbers, we have the ability to adjust pitch and time independently. And so that's a part of most DAWs. Be able to identify the path of a digital audio recording scenario and also the digital audio playback scenario, and I'll get to that in following slides. I'll also ask you to label parts of a DAW. I know we're mostly familiar with that because of the work you're doing in the lab, but it's still important to be able to understand what exactly the parts of the DAW are. So the recording and playback paths are simply, and we can visualize them with real gear, that we must use an input transducer to convert from acoustic audio to analog. That analog signal in an XLR cable is mic signal. That's this in parentheses means mic level signal. That goes into the digital audio interface. Inside the digital audio interface is the ADC, right? And so we connect that digital audio interface to a computer through most often a USB cable, and that is a data cable. So this is the digital realm. This is still electrical analog audio. And so you can see on the front of our digital audio interface, we have our XLR input, we have our gain input knob, we have instrument level plug, and our monitor output dial. And those things are also important to be aware of. There is our phantom power right here. And so again, that is extremely important to know where these things are. On the output side, we're sort of reversing that process where we're going from the computer. Data is being sent to our digital audio interface. That interface is then sending out analog electrical audio to your headphones or to your studio monitors. Either way, they're being sent with line level signal. That is line level signal. So this is a powered studio monitor because it has a power button and a power supply. Otherwise, there are ways to connect to your line level signal to the back of your monitor. So these signal paths are what we're talking about. Input transducer to your digital audio interface to your computer for digital audio recording. Know the difference between your analog and your digital realms and what kind of signal is at each side. I'm sorry, this should be a different color. The color should be reversed. But on the digital audio playback, our computer is sending data to the digital audio interface again, and then we are sending our line level signal to our output transducer. So these two signal paths are very important to know, and I also added some terms to associate with each part of this path, each side. Finally, I'll ask you to label parts of a digital audio workstation. This is very familiar to us. This is GarageBand's window in our last project for Module 1. And again, I'm pretty sure we are very, very familiar with this, but I wanted to put this out on the exam just as a way to cover all the bases and make sure that we're all knowing what we're doing with this. The input gain and the output master level, the timeline and the time window, transport controls, your playback cursor, which is this line here, panning, mute solo, and then your plugins finally down here. And this is also trying to show a region in the DAW. So if you associate terms with with these visualizations of what we're using in the lab, it should really help you prepare and be ready to go. Also, of course, you can use your study guides from the last few weeks to prepare for the exam. As always, if you have questions, reach out to me. I'd be happy to help.